PAL. Notice what it says here. For the PAL, there are 6 inputs and 4 outputs. That's the picture on the right. 6 inputs, 4 outputs. With each OR gate having 4 input terms. Each OR gate notice, has 4 inputs to it. Every one of them is an AND gate. When using PAL, the output of each AND gate goes to only one OR gate. Notice this output of this gate does not go to this, or that. Only goes to that one. It's pre-designed. Thus, there is no sharing of terms. If you have the same term that shows up for this function and that function, you can't share them. With the PLA, if it's the same one, notice like this one, A, B bar, C bar here, you can share it between this function, this one, that. This one you can't share. You got to make one for each one. Now sometimes you need, we said let's say F might need like 6 AND gates. If that's the case, since you only have 4, you got a problem. So what you want to do in a case like this, sometimes we take one of these outputs and feed it back in as an extra source of input. So here we go. The output of some of the OR gates is available as another input. So the output of this sometimes becomes an input. We grab it and use it again.
If we have like 8.
If you have, for example, F equals 8 of these or 7 of these, you need 7 AND gates. You only have 4. So what are you going to do? You take 4 from here, 3 from here, and you feed this as part of that actually input there. Yep, I will be doing some examples. And this will allow for more than, it says 4 AND gates in one example. And this is what the circuit looks like. I made some copies of that so I don't have to redraw this. Last thing I want to do is redraw that. So that's I just ran there and made some copies for it. So let's take a function. And here's my function. I have 3 functions, f, h, and g. F of A, B, C, and D equals. And this already, somebody did the K-map for me. It's AB bar, C bar, plus CD. The second one, H, of A, B, C, and D. And this one, A bar, B, C bar, plus A bar, C, and D, plus A, C, D bar, plus B, C, and D. And the last one, G. So you got to do the K-map for each one of these. You want to simplify them as simple as possible there. A bar, C bar, D, plus A, C, D bar, plus A bar, B, D. And now I'm going to build that circuit. I'm going to use, we said for this, I'm going to use PAL. I'm done with the PLA and the decoder, so I'm going to use PAL, Programmable Array Logic. Here's one of my PAL chip. I got it right here. This is the inside of it. I'm going to have 3 inputs. Let's see what 4 inputs. A, B, C, D. Here's one, A, B, C, D. Let's look at F. That's the first one for F. F has how many AND gates? 2. 2 AND gates. So what's attached to them? A, B bar, and C bar. And the other one, C and D. C and D.
Technically, if you run out of room, could you add more AND gates?
You can't. It comes this way. The chip comes that way.
Unless you have two chips,
No,
right?
the chip. You can buy another set of chips, but it comes with 6 inputs, 4 outputs. Yep. Now, my only concern is this one, this AND gate. You know, and I'm always nervous about picking some noise. Yesterday, I was sitting in my office listening to the radio station WEI about the Patriots, and I went to plug in my iPhone. I got the cord for it, and I have it plugged in the back of my Mac machine sitting on the front. And I didn't plug in my computer, my phone in it, and I hear all that noise. I can hear that lousy signal there. So to make sure I don't get bad noise, bad signal, what I might want to do, kill these 2 gates to make sure I never get anything crazy from them. And if you want to kill them, for safety, what do you attach to it? If you attach A and A bar to it, both, you guarantee this will never be 1. It's always going to be 0. So a lot of times you see us do that, attach one input plus its complement. Doesn't have to be A, any one of them. That guarantees that this is always 0. It's not going to be a factor. This is always 0. And the only thing you're going to get is the result of these 2 gates.
Oh, so that template that you're using, will you give us that during test?
This one?
Yeah.
Yeah, that one actually, you'll get that one. Yeah.
Okay.
Now, the H1, it has 4, can see it. I'll push it a little bit there, or can you see it? Yeah. It has 4 gates. The first one, A naught, B, and C naught. Just knowing where each one is, just to make sure your eye stays focused. The second one, A naught, C, and D. Which one is D? This one. The next one, A, C, and D naught. And the last one, B, C, and D. And notice I'm using all these AND gates, so I'm good. I don't have to kill any of them. That's H. And the last one is G. G is going to be A naught, C naught, and D. The next one is A, C, and D naught. And the last one, A naught, B, and D. And to kill the last one, I can do D and D naught, C and C naught, whatever. And that guarantees this one is a 0 always. So it's not a factor. I don't care about the last one's not connected. But again, if that bothers you, you go like this. That guarantees there's nothing coming out of it. But it's not attached anywhere. So you don't even have to do that. That'll make sure this is always a 0. I'm not using it anywhere. What do I care?
Couldn't you just use the complement for it, or?
1 and its complement. That's what I did.
No, I'm saying just the complement.
No,
Complement?
because what happens if D is 1? The complement is 0, right? That's fine. What happens if D is 0? What's the complement?
Oh, then it's
1. So you don't know what D is. So you got to do a function that's complement. So when you only have 4, it's not bad. But what happens if now one of these has a lot of them? More than 4. That's the next example I'm going to use. Okay. Let me make one up. Let's say I have these 3 functions. I got to think about one. F of A, B, C, D again is going to be the summation of, I'll give you the midterms, 0, 1, 5, 6, 9, 12, 14. And G of A, B, C, D equals 0, 1, 5, 9, 10, 14, 15. And let me look at a FGH. The midterms of 0, 1, 2, 5, 6, 9, 10. That's it. That's good.
You forgot a comma in the top one between 9 and 12.
9 and 12. Oh, yeah, thank you.
Is that it for it?
That's it. Remember, we're designing this using the PAL. That means I gotta do the K-map for each one, simplify it, and if I have more than 4 AND gates, I might have a little problem, especially if every one of them has 5, 6 of them. I'm gonna have a bigger problem. Unless I'm creative. Let's look at the first one. K-map. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is for F. Another one for G. This is for G. And the last one for H. Let me go through F and plug in the ones and zeros there. Here we go. I got a 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think I'm good. With that one. Let's look at G. I have a 1 at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. H 1, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's see. To group these, let me highlight them. I can go this way. I don't know if you can see that on the screen. That's a possibility. This is a to get this one, this is a possibility. Can you see that? To get these two, there's a possibility. And so I went this way. I'm going this way. I'm going this way. How about this one with this? And how about this one with that?
You don't really have any other choice, do you?
Nope. I mean, instead of taking it by itself,
Other than
Yep.
that.
which will not be a good move. So let's see what we have. A0, B0, and C is 0. That's this one. This one here, A is 0, B is gone, C is 0D. This one here, which is what? B, C, D naught. This with this, these corner. And that looks like what? B naught. B naught, C naught, D. And finally the top and the bottom, which is what? A, B, D naught. That's already 5 of them. I'm looking at this one. That's one group. That's another group. It looks to me that's another group, right? That's another group. And the one here is going to be what? So here's one group. There's one group. There's one group. One, and maybe the one with the one. So the first one, A naught, B naught, C naught, plus this one, A naught, C naught, D.
It's the same thing.
Yep. This one here, A, B, C, right? This one here, A, C, D naught, and finally that this end with that end, which will give me what? B naught, C naught, D. What I noticed, some of you already noticed that this gate was the same so far. See it? That's the top one. And the one next to it was the same. And that corner is the same. That's this and that. And it looks like it's going to be the same thing right here. See him? Right here. Right here. I got to take this So this one here and this one here. That's the first two. A naught, B naught, C naught, plus A naught, C naught, D. So these two are the same. Plus, let's take this one here. This is A naught, C naught B. A naught, C, D naught. What about if I take this one with that one? B naught, C, D naught. And the last one again, that end piece. See, that end piece keeps coming back, which is B naught, C naught, D. When you have stuff like this matching, that's actually good for us. Now, how many gates? 1, 2, 3, 4, 5. I got a problem. How many gates? 1, 2, 3, 4, 5. Got a problem. 1, 2, 3, 4, 5. Got a problem. So now we have a problem here. So what are we going to do? Let me write my functions down here so I'll have that sheet. So here's f, A naught, B naught, C naught, plus A naught, C naught, D, plus B, C naught, D, plus B naught, C naught, D, plus A, B, D naught, I think. G, A naught, B naught, C naught, plus A naught, C naught, D, plus A, B, C, plus B naught, C naught, D, plus A, C, D naught. I just reversed these two, trying to line them up. And H is going to be the same thing. A naught, B naught, C naught, plus A naught, C naught, D, plus A naught, C, D naught, plus B naught, C naught, D, plus B naught, C, D naught. Now what I'm noticing that the one I'm going to highlight here is the same. All three of them.
You can just use one input.
So what I'm going to do, here's my inputs. We have 4 inputs, A, B, C, and D, and we get these two empty. Let's attach these gates to it. Let's attach these 4 gates to it. Well, I have 3 of them actually. The first one is what? A naught, B naught, and C naught. That's this guy. That's the first term. The other one is going to have what? A naught, C naught, and D go into it, the second one. And the third one is going to be what? B naught, C naught, and D. So these are the common ones for all 3 of them. And to make sure this never goes on, I want that to stay 0. I'll go A and A naught go into it. I'll make sure I kill it. I don't want to take a chance with it. But what am I going to do with that? What I'm going to do with it now is move it back up there and use that as an input now. Here we go. Loop it around here. Make it nice and neat, clean. Got a little extra wire there. So this becomes common, actually. This becomes an input. So anytime I attach to this one, that gives me all 3 gates. So if I want to go to F and make that my F, The three green ones, I can get them by going right there. That picks all three of them, all three green ones. See them? 1, 2, and 3. I got them all. Now I need two more gates. One for B, C naught, and D. This is B. This is C naught. Where is it? C naught. And this is D. And the last one is A, B, and D naught. So this one actually has this AND gate, and these three AND gates. All three of them going to be connected here. Add them together. And to kill the last one, I want to make sure this is not sitting there doing nothing. That's always a 0. Now the next one is G. The same thing, the three gates common. I connect them to the top one, so I got the three gates going in now. What else I have? A, B, and C. A, B, C. And the last one, A, B, and D naught. And let's kill the last one. That's a 0. And H, the last one, again, I want all three gates going to it. That's this one. And now I'm going to have two more gates, A naught, C, and D naught. A naught. Where's C? I think that's C. And D naught. And the last one, B naught, C, and D naught. B naught, C, and D naught. And let's kill the last one. And now I just got my function. I was a little creative. I try to find some gates that matches and use them as common, because you can't take the output of this gate, feed it to this. The only way is the common ones, you can feed them back and use them as an input and grab them anytime you want to use them.
Question, what if you had two groups of the same, for
You can do-
example?
Yep.
How would you attach that if you only have four OR gates
If I have two groups, I attach two of them to this,
to the...
to one of them, and hopefully I get the rest is enough, you know?
Mhm.
Now, if each one has 7 of them, then I got a problem. Because if I grab this to this, I only have 2 outputs. So if I only have 2 outputs and I get 2 groups the same, I can make this one group, that's another group, feed them back to this, and that's to that one, and grab them. But if you still have 4 or 5 outputs, then I got a problem. I need another chip.
But could you attach that last, for example, if the two groups, actually then it would be one group. You know what I mean?
Now, if this didn't match, for example, let's say I didn't have this one, the last one, I would have made this one just these 2. And I added that gate here instead of 0, 0. I will put it there. I will put that here, and I will leave that out. You know. Notice the book does a little bit of programming here. XOR, introduction to Verilog here. And they can do some programming languages that will go through them and find what the sum and all that. We don't have the program here, so We just do everything by hand. Now, let's see if I can find another example in the solved problems. Solved problems, here we go. I need that thing. Big one. Okay. I'll take one in the back of the book. I'll do with the ROM, PLA, PL. This, by the way, our book has that picture in it. So when you do the homework, you get that picture already there. Just gotta, that's the PAL. You just gotta use it. This is the ROM. See the ROM? It's already made. Just gotta connect what's going to it. I should have made copies of the ROM. And this is the PLA, a blank one. Our book does try to help us there. So instead of redrawing everything, it's use these templates so you don't have to waste your time drawing them. You know, just connect the right pieces. I didn't make copy of them, so I'll keep them clean so I can make copies of them. 6 inputs, that has only 4 inputs. But these will come with 6 inputs for this one. This particular one has only 4 inputs. Let me take a problem. We had some homework last time. And this is implement using a ROM, implement using PLA, implement using PAL. Give us one that's good, like lots. I'll make one up, I don't know. Let's see. Wild guess. F of A, B, C, D. We'll say 4 inputs. Go ahead. Which one you want it to be 1? Between 0 and 15. Give me as many ones you want to. Don't go crazy.
3, 5, 7, 9.
Done?
15.
Okay. We just put some numbers. B or F, G.
The opposite, maybe? The one that we don't.
That's-
0, 1, 2,
We did 2, 3,
4,
4, 5. What else? 6, 9,
11.
11, 12, 15. I don't know. And I'll use H. I'll go 0, 1 with this because you wanted 0, 1. 5, 6, 9, 13, 14. I'm just making things up. I have no idea what's going to happen here. I don't know if they can fit on one. Actually, we're going to do them first with ROM. We'll do, okay. Let me do this one. Since I started this one, the PLA and PL actually, you need the K-map for them. So either way, so we'll do the PL and PLA first, then we'll do the ROM after that. This is for F. I don't know why I did 3. I should have made just 2 output. More work for me. A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0. And let me put the ones for them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0, 1, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boy, we're in trouble here. Nothing really matches there. When I'm looking for something common so I can use it, wrap around, unless I'm blind. The only one, oh no.
You don't have really any comment.
No, just these two. So if I simplify, let's see, this one, easy one, quick one. That's what? C bar D plus, this will be what? B, C, D bar, and up and down here. And that's, what do we got there? A naught, B naught, C naught, right? Ugly, ugly, ugly. I know once you start giving me odd numbers, they're not going to match. So this will be what? A naught, C and D. I can take these two guys together. That will be what? B, C, D. Yep. Each one individual, now by itself.
Yep. You could do the other two.
Which other two?
Position 5. Or
11 CD.
Okay, there's no sharing here. So this one,
Never mind.
A, B naught, C naught, D. This one,
No, you can do two.
no, they're two different K maps. Can't, this,
No.
you think of this and this?
No, that same one.
and down.
Down one.
Position 5 and position 7.
Instead of using one.
Oh, I see, up and down, I see, wait, yeah, okay. This one,
It's A dot B.
so that'll be A bar, B, and D. This one by itself, which is A, B bar, C, and D bar. This one, A, B, C bar, D bar. I can take this, I can take this, I can take I have a few options here, because I can go this way to get this one. I can go this way, then I can go this way and that way. Which one?
With the one you just said, you can take it to the one to the left.
Oh, the one to the left, yeah. See, I was trying to see if I can get some matching, like this with this,
Oh, yeah.
this, so I can use the same gate.
So in that case, you might not pair that one.
Yeah, I might not pair this one either,
Okay.
so I can use the same gate here, right? So I have two gates here, but I still need one more. Ah,
Would that, mess up the PLA?
well, now I'm gonna need an extra chip now. Well, the good, I might be okay. 1, 2, no, I'll need, yeah, one more. See, I will go with this separate, that separate, because that will give me
You can just,
AB, let me see, I gotta look closely at it, AB, C bar, D bar. I'll take this separate to match this one, I'm trying to color them. And this will be what? A, B bar, C bar, D.
Well, you can then probably grab the other one, the two instead of having in the first one. If you're gonna be doing those anyways.
This one?
Yeah.
Yeah, it doesn't help me. Because I still gotta grab that one.
No.
If I take it, now I can do this and, wait, I might be able to do this and that now. I might be actually.
Yeah, you probably could actually.
If I, instead of taking this with that, if I take it by itself, I might. Let me just take a closer look at it. Which one was that? That's
The
A,
bar.
B bar, A bar, B. And we had these, that's this one. If I take it by itself, A bar, B, C bar, D. I might be able to do it. Let's see, I might be okay. If I take this by itself, that's the same one, right? Plus A bar B, C bar D. Now, I can take, let's see, we'll see if that works. I can take this with this, these will be common, that'll be 1. A bar, B, and what do we have? D bar. And I can take these guys together. That will be what? A bar, B bar, C. I think I'm okay. Now I'll take these two guys together. And that will give me A, C, and D. I think I'm good. Because there's 3 of them the same. This one is okay. 3 the same. It leaves me 1, 2, 3, and that's 4. 1, 2, 3, that's 4. That will work actually. That will do it. As crazy as this problem is, I think we found a solution to it. So sometimes you don't want it actually to simplify. Here we go. Let me write F on the top. Which one's which? The ones with 4 are the individual ones, so I'll put them separate with 4 terms in them. Well, not all of them. A, B, so that's the top one. So that's A, B, C bar, D bar, plus, that's good. So for G is the same thing, that's this one. A, B, C bar, D bar. What else we got? Which one is this? A, B bar, C bar, D, that's this one. A, B bar, C bar, D. A, B bar, C bar, D, that's this one. Oh no, oh no, no, not that's A, B bar, C, that's this one. The next one is this one, which is what? A bar B, C bar D, A bar B, that's this one. A bar B, C bar D, that's this one. So these are the matching ones. So the rest, just write it down. B, C, D plus A bar, C, D plus A, B bar, C, and D bar. Done with this. This one I get the top three, the first three. What's left? A bar, B, D bar plus A bar, B bar, C plus A, C, D. Done. And the last one, H, C bar, D plus B, C, D bar plus A bar, B bar, C bar. I need the matching ones. There's three matching ones right here. So this is F and G. The matching ones. A. This is A. B, C, and D. B, C bar, D bar. That's one of them. The next one. A, B bar, C bar, and D. The next one. A bar, B, C bar, and D. And the last one I'll kill. So these are the matching ones. I'm going to take them, loop them around. Doesn't matter which one you attach it to. So now I'm going to grab it for F. These three gates, that's this one. And for G, that's this one. I'm using them for both. So I get these three gates. So what do I need to attach? B, C, and D. The next one, B, C, and D. The next one, A bar, bless you, C, and D. And the last one, A, B bar, C, and D bar. That's F. For G, I need to attach A bar, B, and D bar. A bar, B bar, and C. I'm going blind now. The last one, A, B, C, and D. And that's G. And H is straightforward. C bar and D. D is right here and C bar is here. B, C, and D bar. And A bar, B bar, and C bar. And I'll kill the last one. That's a 0. Woo! We got it.